Hi everyone, myself MUVSSR KRISHNA. I am handling heat transfer for your in the current semester. Now let us go into the first PPT or first video recording, that is introduction and modes of heat transfer. So after this session, you will be knowing what do you mean by heat and what do you mean by mass transfer and what are the different modes of heat transfer. So first, before going to the definitions of heat and mass transfer, first let us discuss about what is the difference between thermodynamics and heat transfer. Why I ask this question is thermodynamics is also branch of science which deals with uh, thermal means sciences heat that is under motion. So almost it is also equal to the heat transfer. Then why to study the heat transfer, which we have already covered in your third semester, that is thermodynamics. The main reason for studying heat transfer is in heat transfer we can find the temperature of any particular body of a particular body in the entire process or in any situation of the process we can find the temperature. But in thermodynamics we can find only the temperatures at initial and final stages of the completion of cycle. So that is the major difference between thermodynamics and heat transfer. So now let us discuss about heat and mass transfer definitions. So heat transfer is nothing but flow of energy which is caused due to temperature differences. This is entirely based upon second law of thermodynamics. So which is where the heat flows in the direction of decreasing temperature. This transfer of heat can be either in a solid or a liquid or in a vacuum also. So we shall discuss further in the next session. So now what shall we discuss? What do you mean by mass transfer? Mass transfer is nothing but net movement of mass from one location, either upcoming of the stream or downflow, is nothing but your mass transfer. In general, the region from high to low it will be only transferring the mass. So for example, if you take evaporation of water from the atmosphere, okay. So now we shall go for what are the different modes of heat transfer. In general, there are three modes of heat transfer. One is conduction, convection, and radiation. So before going to discuss further, let me take this example for explaining three of these. So if you see this, when you are heating water, the vessel also get heated. When you touch the handle of the vessel, there may be some transfer of heat your body to the vessel. So you'll be a little bit a shocked feeling. So the transfer of heat from a higher molecule to lower molecule is nothing but a conduction. I'll explain in detail with the example I'm explaining. Whereas the convection is transfer of energy due to density variations, and the radiation is which is takes place in the vacuum. So now let us consider about conduction. So which I started initially. Conduction is a mode of energy heat transfer which takes place with respect to higher energy molecules to a lower energy molecule. Suppose if you take a body where we will be having n number of molecules. Some may be with higher energy and some may be with lower energy. When a higher energy molecule interact with a lower energy molecule, what will be happening? There will be transfer of energy. So that transfer of energy is nothing but conduction. So the conduction will be generally takes place in solids and in liquids also, but due to collision or diffusion of electrons. So for this, Fourier has given a law that is also called as Fourier law of heat conduction. So if you take a suppose a wall like this of inlet temperature T1 and the exit temperature is T2, whenever a body is transferring heat from higher body to inlet to outlet, the transfer of energy is directly proportional to its surface area and also its change in temperature to the with respect to the thickness. So that's why it is called as rate of heat conduction Q is directly proportional to area into temperature difference by thickness. That is given as Q of conduction is equal to Ka T1 minus T2 by Tx. Then what is called as this K? This K is a constant, proportionality constant, and it is called as thermal conductivity. It is nothing but ability of material to transfer heat or to conduct heat, and the units are the watt per meter Kelvin. and it varies from material to material. In gaseous, as it is tightly packed, if we increase the temperature, the molecules will be very, very closer and the thermal conductivity will be also increases. Whereas in liquids, if we increase in temperature also, the molecules will be get tightened so that the heat transfer rate will be also increases, which means if there is a rise in temperature, the thermal conductivity also increases for the material. If there is a decrease in temperature, the thermal conductivity will be decreases. So this is one of the important question or a topic. So these are the different thermal conductivities for different materials and different properties. Okay, it will be very high for high power laser diodes and it will be low for core temperatures, and it's very good insulator. Air is a good insulator, and you can see the diamond is having 2450 watt per meter Kelvin. Okay, so next is convection. Initially I explained convection is a mode of heat transfer which takes place with the help of density. Okay, or if we can say that due to density variation, if there is a transfer of heat from one body to another body, then it is called as convection. Suppose if I take an ice cube and place it in a room, what will happen? The ice cube will be melting slowly. Am I right or wrong? So, which means the thermal conductivity of ice is different. Sorry, the density of the ice is different, whereas the density of the room is also different. So, due to this density variation, the ice is going to uh, lose its property and it is converted into liquid. So, if it takes place in the presence of a medium also, we can say it as a convection. Convection is a mode of heat transfer which takes place in the presence of medium. And this convection is of two kinds. One is forced convection and the other is free convection. We all know free convection, just what I explained. If you take ice cube in a room and it will melt, it requires it to melt. What will happen? Without any external sources, it is cooling down. If suppose I place the same ice cube and place it in a air conditioned room or a ceiling fan room, it melts faster. Am I right? So this is the difference between a forced convection and a free convection. For convection, Newton has given a law that as it is a bigger room temperature, as it is a bigger area, we cannot take the entire section of the area. So the rate of heat transfer is directly proportional to its surface area and change in temperature between the surface and ambient. Q is equal to HA Ts minus T infinity, where H is called as convective heat transfer coefficient. Next mode of heat transfer is radiation. Unlike these two, radiation is a different mode of heat transfer which takes place in the presence of without any medium. So, for example, if you take our brain, what will happen? In brain, there are n number of nerves, but there is a transfer of molecules, transfer of energy from one nerve to another nerve. So, within the space, if there is a transfer of heat, then it is called as radiation heat of transfer. In fact, the radiation will be the faster than light, suffers no attention to vacuum. For this radiation of mode of heat transfer, Stephen has given a law, and its law is called as Stephen-Boltzmann law. He states that the rate of heat transfer is directly proportional to its surface area and fourth power of its absolute temperature. And that is Q is equal to sigma A into T power 4, where sigma is called as Stephen-Boltzmann constant. And it is 5.667 into 10 power minus 8 watt per meter square Kelvin power 4. So these are the applications where we can see general daily applications of radiation heat transfer. Okay, these are some important short and long answers questions which were covered in your previous examinations. Thank you.